Hey everybody, welcome to homework 3.8. Today we are looking at more exponential functions, and this time we are really making sure that we are writing them as functions. So that's one of the important parts about today's lesson and today's homework is now that we're looking at these exponential equations, we're thinking about them in terms of functions. So for an experiment, a scientist designs a can 20 centimeters in height that holds water. A tube is installed at the bottom of the can, allowing water to drain out. At the beginning of the experiment, the can is full. Every minute after the start of the experiment, 2/3 of the water is drained. So as I'm doing that, I'm automatically thinking about 2/3 of the water is drained means that 1/3 remains. And I'm just going to put a note for myself there. It says, explain why the height of the water in the can is a function of time. So this means because at any given time, there is only one possible water level. So I can't say, oh, at 2 seconds, the water level is 20 centimeters and 15 centimeters, right? It can only be one water level at a time. The height, h in centimeters, is a function of time, t in minutes since the beginning of the experiment, is h equals f of t. Find an expression for f of t. So the height, or f of t, equals our starting amount, which is 20. We're draining 2/3, which means that 1/3 remains. So our factor is 1/3 to the power of, or to the exponent t. Find and record the values for when t is 0, 1, 2, and 3. So when it's 0, obviously, when t equals 0, then f of t equals 20. That's our starting amount, so 0. And actually this will be shorter for me to write this as this. When t equals 1, so f of 1, then this is 1, so that's 20 over 3. And if you want to convert that to decimal form, you can. F of 2, sorry about that extra 0, that was an accident, equals 20 times 1/3 to the power of 2. So in your calculator, then, you're going to take 1/3, or 0.3333. Make sure you use that 1/3 because all those 0.33333s mean something, and so your answer will be very different if you don't include them. Squared times 20 is going to give us 2.2222. So f of 2 equals 2.22. And then f of 3 equals 20 times 1/3 to the third power. So again, 1 divided by 3 to the third power times 20 gives us 0.74. All right, find f of 4. What does f of 4 represent? So f of 4 equals 20 times 1/3 to the power of 4. So 1 divided by 3 to the fourth power is 0.01234567 times 20 is 0.25. We'll round to that. And so that represents 4 minutes since the start. There is 0.25 centimeters left of water. It says sketch a graph of f by hand or by using graphing technology. So you can use your graphing calculator to take a look at that graph. I'll show you in a second on my phone what that looks like. Or you can go ahead and just sketch this out by hand. So we have all of our values, right? We have our table here, our input of time, and then our output of f of t. 0, 1, 2, 3, 4. And right, it is decreasing exponentially. So we have 20, then it's 20 divided by 3, which I'm going to go ahead and give you a more precise decimal for that if you didn't already do that, is 6.67 rounded. f of 2 was 2.22, and f of 3 was 0.74, and f of 4 was 0.25. All right, so knowing this here, I'm going to make our graph, right? The highest point that it's going to be at is 20. And we're starting at 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. We'll go ahead and put that there. Now, in terms of our descending values here, I'm going to go ahead and mark 10 in the middle. All right, then you know that 5 is here, 15 is here. And then our first starting value is at 20. Let me change the color here. So we're starting here. And then after 1 minute, we've lost 2/3 of that value, right? As it told us. And so that means only 1/3 remains, which is 6.67, so just above our 5 here. At 2 minutes, we have 2.22. At 3 minutes, we have 0.74, so under 1 there. And at 4 minutes, we have 0.25, so very close to being fully drained, right? It's decreasing exponentially. All right, now let me show you on the graph what that looks like on here, just so you can have an idea. So I'm going to go to my y equals, all right, and I'm putting in our equation. So 20, open parentheses, 1/3, close parentheses, to the power of x. And then I'm going to graph that. Now, you can see that this graph is not super great looking, right? It's very, very zoomed out. So I'm going to zoom in and notice that here on my graph, when I looked at the window, I looked at an x minimum of 0 and a y minimum of 0. My x maximum is only 5, right? I didn't go very high on the x maximum. Then my y minimum is 0 because we're not looking at negative numbers here. And my y max was 20 because that was the absolute most amount in there. I'm going to set the y max to 25 just so we can see a little bit above the graph. But then now here, there you go, you can see that this graph matches a little bit nicer to the one that I drew down there. So setting that window, and I'll show you how I have my window set. Setting that window is really, really important when you're using your graphing calculator to graph these. It says, what happens to the level of water in the can as time continues to elapse? How do you see this in the graph? So as time continues to elapse, the water level is getting closer and closer to 0. Water gets closer and closer to being 0. All right. And we see that because as this graph goes down, and I'll show you again in the graphing calculator, right, that if you look here, this line is getting closer and closer and closer to 0, to y being 0. And so that water is draining, 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 getting all the way down to the bottom. All right, a scientist measures the height h of a tree each month. M is the number of months since the scientist first measured the height of the tree. All right, so already I'm thinking that height is a function of time or height of m, right? In the height h, is the height h a function of the month m? Explain how you know. So yes, because at any given month, the tree can only be one height, right? So I can't have in 2 months after it's 10 feet tall and 20 feet tall. It can only be one height. Is m, month, a function of the height? Explain how you know. So this is no, because for a given height, there could be, be more than 1 month. So let me give you an example. I could say in January, the tree was 10 feet tall. And then in February, it was also 10 feet tall. So if the month is a function of the height, that height would be the input. And so I would say, oh, well, the input is 10, because that's how tall the tree is. But the tree could be that tall at more than 1 month, right? And so if any given input has more than one possible output, it is not a function. So the second one is not a function. If it's helpful, you can also create a table to show yourself, right? If I were to look at a input of month and an output of height, right? If I look at January, February, March, each one of these can only have one possible height, right? But if I'm looking at heights and then months, if I put 10 here, I could potentially have 2 months that are listed as being that tall. All right, a bacteria population is 10,000. That's our starting amount. It triples each day. Explained by the bacteria function. B is a function of the number of days D, since it was measured to be 10,000. So B is a function of days because on any given day there is one possible number of bacteria. Which variable is the independent variable in this situation? So the independent variable in this case is days. Again, time. Independent is input, so the days. And then write an equation. So B of D equals 10,000, our starting amount, times, it says it's tripling each day, 3 to the power of days. It says, is the position P of the minute hand on a clock a function of the time T? So for example, if I were to say the input is 12:10, is there only one position of the minute hand? And so the only possible position that the minute hand could be would be at the 10-minute mark, right? So at 12:10, we are at the 10-minute mark. The hand of the clock can't be at the 15 if it's 12:10, right? It can only be at the 10-minute mark. So yes, that position is a function of time. Is time the function of a position of the minute hand on a clock? So for example, if the minute hand is at, right, let's say 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So if the minute hand is at the 3, right? It's 15 minutes. But could there be more than one time for that when that minute hand is in that clock? Yes. So this is not a function, because if the minute hand is pointing to the 3, it could be 2:15 or 3:15 or 4:15. It could be any variation of time because that hours piece, right? So this part is not a function. All right, number 5, the area covered by a city is 20 square miles. The area grows by a factor of 1.1. So it's giving us our factor there since it was 20 square miles. Explain why A covered by the city in square miles is a function of T, the number of years, since its area was 20 square miles. So again, A is a function of miles because for any time, right, any specific time, there is only one possible area. So I can't say at, 3 years, it's both 50 square miles and 70 square miles, right? In 3 years, it's just a given number of square miles. An equation A of T equals our starting amount 20 times. It gives us the factor of 1.1 to the exponent T, where T is years. All right, this graph shows an exponential relationship between x and y. Write an equation representing this relationship. So we are going to say y equals, or you could say f of x, but it says between x and y. Our starting amount is 50. And then in this case, we're increasing, so our number should be greater than 1. And it looks like each time it's doubling, so our factor is 2 to the power of x. It says, what is the value when x equals -1? So even though we can't tell exactly, we know that this has to be 25 because the number before 50, if we're going multiplying by 2 to increase, going backwards, we would divide by 2, and this would be 25. And we're looking at -2, this would be -12, or not negative, positive 12.5. Right, again, having 25 would give us 12.5. And if you like, you can put it in your calculator. You can substitute 50 times 2 to the negative first power, or 50 times 2 to the negative second power. This is the same as 50 times 1/2. And this is the same as 50 times 1/2 squared, or 1/4, right? So 1/4 of 50 will give us 12.5. All right, these parts right here are a bit of a review. Here is an inequality: 3x plus 1 is greater than 34 minus 4x. Graph the inequality, the solution set. So we're going to solve for x here. In order to do that, I'm going to add 4x to both sides. So I'll get 7x plus 1 is greater than 34. Subtract 1 from both sides. And we'll get 7x is greater than 33. Divide both sides by 7. And so when you do that, you will get 33 divided by 7 gives us 4. So x is greater than 4.71. So here-ish. And it's greater than, so it's going to be an open circle, and greater than to the right. Here are equations that define 3 functions. Which function is the largest? Okay, so for these, you're plugging this in, right? If I plug in f of 100, I get 400 minus 5, which is 395. If I plug in 100 here, I get 4 times 100 minus 5 is 95. So 4 times 95 gives me 380. And then here I'm looking at 100 divided by 4 minus 5, which is going to be 25 minus 5, which is 20. So in this case, f of 100 is the largest. All right, if we look at -100, then we have -400 minus 5 gives me -405. That's pretty small. So we have 4. Uh-oh, what happened? Oh my goodness, I don't know what happened here. Okay, well, oh, there it's back. Oh, that's weird. Okay. So we would have 4 times -405, right? Because -100 minus 5 is -105, excuse me. -105. And so -105 times 4 is -420. And then we would have -100 divided by 4 is -25 minus 5 equals -30. So in this case now, our largest number is h of -100. And then last but not least, you're going to plug in these fractions. So 1 over 100 is 1/100th, right? So 1 divided by 100 gives you 0.01. So you can plug in 0.01 if that's easier for you to do. But 0.01 times 4 plus 5 gives us 504. And then 0.01 minus 5 gives us -4.99 times 4, which is -19.96. And then here, what do you think happens here? So if we have 0.01 divided by 4 minus 5, we get negative 4.9975. And so in that case, this one is our largest number. Oh, you know what? I did something wrong. I think 4 times 0.01 is 0.04 minus 5 is negative 4.96. Okay, so this one is still the largest, but it's by very little. This is wrong. I don't know what I did there. I think I added instead of subtracting. Sorry, my bad. It's minus 5. Okay. This review here is having you use tables and practice functions. So it says use a table below to write an equation that represents the relationship shown. All right, so if we look at this, we can see that what is happening each time appears to be that we are multiplying by 4. All right, so this tells me that my starting amount, f of x, equals 0.2 times a factor of 4, because it's increasing multiplied by 4 each time, to the power of x. Using the table, if h is a function of g, what value belongs in the blank to make the statement true? So when is g a number that gives us an output of 250? So that would be here, and that means our input is 2. All right, that's it for your homework. If you have any questions, feel free to reach out. Please make sure to go back up and fill in your code word for today. Your code word for today is star. And if you have any questions, please text. Happy homeworking. See you tomorrow.